Example 1, using the substitution rule. We want to find the integral of x cubed times the cosine of x to the fourth plus 2 dx. Okay, let's go ahead and write that out here. So we have the integral of x cubed times the cosine of x to the fourth plus 2 dx. Okay, so the first thing we want to do is we want to take a look and say, okay, well, can we shift this around a little bit? So we can rewrite this as the cosine of x to the fourth plus 2, and then write this as times x cubed dx. And what this allows us to do is, what we're going to do is we're going to let u, so over here, we're going to let u equal what's inside the parentheses, which is x to the fourth plus 2. Okay, now what we're going to do is we're going to take the derivative. So we have du, which is going to equal the derivative of x to the fourth, which is going to be 4x cubed, and that's dx. Okay, and so now what we want to do is we want to be able to solve for x cubed dx, because that's what we have here. So in order to do that, we have to divide both sides by 4. So therefore, 1/4 du is now going to equal x cubed dx. So these are the substitutions that we want to work with. Okay, so now what we can do is we can then rewrite this. Okay, we can say that this becomes the integral now of the cosine of, well, we know that x to the fourth plus 2, we let that equal u. So this is the cosine of u. Okay, times, we know that x cubed dx down here is equal to 1/4 du. Okay, and so now we can just kind of shift this around a little bit. We can factor out the 1/4 outside of the integral. And then what we have is the cosine of u and then du. And now that allows us to then find the antiderivative. So we want to find the antiderivative of the cosine of u, which we know is the sine of u, and then that's plus c. And then the last thing we need to do is now we need to replace that u with what we called u to be at the beginning, which is x to the fourth plus 2. So therefore, this now becomes 1/4 times the sine of x to the fourth plus 2 plus c. And so we can see here that, notice that at the final stage we had to return to the original variable x because u is equal to x to the fourth plus 2. Okay, now let's discuss this problem here a little further. Okay, the idea behind the substitution rule is to replace a relatively complicated integral by a simpler integral. This is accomplished by changing from the original variable x to a new variable u, which is what we did, that is a function of x. Thus, in this example, we replace the integral x cubed cosine of x to the fourth plus 2 dx by the simpler integral of 1/4 cosine of u du. The main challenge in using the substitution rule is to think of an appropriate substitution. You should try to choose u to be some function in the integrand whose differential also occurs except for a constant factor. This was the case in example 1. If that is not possible, then you try choosing u to be some complicated part of the integrand, perhaps the inner function in a composite function. Finding the right substitution is a bit of an art. It's not unusual to guess wrong. If your first guess doesn't work, then you try another substitution.